Hi everybody. In this video we are going to discuss about how exactly we can avoid the deadlocks. So we are basically using the deadlock prevention algorithm to prevent the deadlocks either by using the direct method or indirect method. If we are using direct method, then we are going to prevent the circular weight condition to occur. Or if you wanted to prevent the deadlocks indirectly, then you have to avoid the conditions like mutual exclusion, hold and wait, and no preemption to avoid the deadlocks. So let us continue now. So whenever we talk about this deadlock avoidance, basically the deadlock avoidance algorithm is going to check the resource allocation state, and it is ensuring that the circular weight condition is not existing. So there is a concept of safe state which is indicating that there is no deadlock at all in the process. So if you wanted to talk about the safe state, it is the state where there is at least one sequence of resource allocation which is not leading to the deadlock. Okay, and if certain sequence exists, then we say that the process is in safe state, and if there is no such a sequence existing, then we can say that the system is in unsafe state. Whenever we are saying unsafe state, that means it may lead to the deadlock. So that's why, as you can see here, if the as the points are indicated, the safe state is nothing but there is no deadlock, and if it is unsafe state, that means there is a possibility of getting the deadlock. Okay, it doesn't mean that all the unsafe states are going to it may lead to the deadlock. Okay, so let us see with the help of an example. So here I have taken the particular system where we are having 12 magnetic tapes or tape drives, and we are having three processes P0, P1 and P2. The requirement of all these three processes are 10, 4 and 9. Okay, so that means they need these many resources for their execution. So if you see the current allocation, each and every process is having its own allocation. Like process P1 is having 5 resources allocated, P1 and P2 are having 2 instance of the resources allocated. Okay, to be precise, let me show you with the diagram. Here it is showing the maximum matrix. That means these are the resources available. For process P0, we can have the requirement of 10 instance of the resource. P1 is having requirement of 4 instance of the resource, and P2 is having 9 instance of the resource maximum. Okay, and currently each and every process is holding 5 instance, 2 instance and 2 resource instance individually or respectively. Okay, so as I have told you, there are totally maximum 12 magnetic tapes. That means maximum 12 instance of the resource is available, and after this allocation we are only remaining with 3 instance. Okay, so you can add this one and find out what is the available vector. So 5 plus 2 plus 2, it is 9. 12 minus 9 is 3. So overall, after the allocation of instances of resource to all the 3 process, we are remaining with only 3 instance of the resource. Now, so this is the maximum requirement, and so this is the maximum requirement and this is the allocation. Now only availability is 3. Okay, so as you can see, process P1 total requirement is 4 and it is already having 2 with it. Fine. So P1 can just fetch the remaining instances required and it can finish with the execution from the available vector. So P1 is going to request for the 2 more resource instances and it will finish with the execution. So after the two instance of the resource is allocated to P1, it is going to execute. That means it is running to the completion. And once it is completing with the execution, it is going to release the resources. That's why I have written here returns its resources. So because P1 has finished with the processing, now allocation is 0 and maximum requirement is 0, and P1 has released all the resources. After allocating the resources to P1, available was only 1 and P1 has released the 4 instances. So total availability is 5 now. Okay, then if you can see the maximum requirement, P1 has finished, P2 requires 9, currently it is having 2. So it requires total of how much? 7 instances, but available is only 5, so we cannot process P2. If you see P0 process, you can see that P0 is already having 5 and the maximum requirement is 10. That means it requires 5 more instances, and if you see the available vector, we are having 5 instances there. So we can allocate that 5 instances to process P0, and P0 can finish with the execution. And after finishing with the execution, you can see that process P0 has released all the 10 resources, 10 instance of the resources. So that's why here available vector is 10 now. P0 has finished with the execution, P1 has finished with the execution. Now only remaining is process P2. Process P2 is having 2, maximum required is 9, that means 7 more it requires. Now because availability is there, P2 is going to get all the resources required and it will finally complete with the execution. Now this is the way in which when we are allocating the resources, each and every process is able to complete its execution. Hence we can say that the system is in safe state. Hope you people have understood this example. Now let us move to the another example. Okay, here this is the explanation of that. Now let us go for the next example where we are talking about the unsafe state. Okay, so now to make the safe state to unsafe state, I am considering that in the initial state the maximum requirement is 10, 4, 9 as usual. The already allocated is also same, resource vector is also same, but the available is also 3. Okay, so initially if you see the initial state, we can see that the entire system is in safe state. Now at certain point T1 or at certain time T1, we are going to allocate the process P2. Okay, that means P2 is requesting for one more extra tape drive or one more extra instance of the state, which I am showing you here. Initially it was 2, now P2 is requesting for one more instance, so that is allocated, hence reducing the availability of the resource to 2 only. Now if you see here, the system is not in the safe state. Okay, so how, let me tell you. As you can see here, process P1 was let me show you here. Process P1 was holding 2 instances of P1 and the maximum requirement was 4. Okay, so 2 is available, 2 more required, availability is also 2, hence we are allocating the resources and P1 runs to the completion. After that, the entire system will look something like this. P1 has finished with the execution, that's why it has released all the resources what it was holding. So availability has increased to 4. Okay, now if you see in this diagram that process P0 is having 5 instances, it requires 5 more because maximum requirement is 10. Okay, so it is highly impossible because availability is 4. Let us go for process P2. Okay, P2's maximum requirement is 9 and currently it is holding 3 instances. So P2 requires 6 more instances for completing its execution. But if you see, the availability is only 4. Hence, because the availability is not fulfilling the requirements of the process, we can say that the entire system is in the unsafe state and it is resulting into the deadlock because both the process are waiting for the other process to release the resources. Hope you people have understood this concept.